musician's graph paper. So the special function that we've been talking about is a log function. Why is log so important for a musician? The log is very important for a musician because all your stats, all your musical writing is actually done on a log scale. So in order to understand that, let's discuss what logs are. So if you were to write a really big number, 29995000000, is there a better way of writing this? And the answer is yes. So you can count the number of digits, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And you could write 2.99 times 10 to the 11. That is easier to write. Or if you were feeling even more like not writing, you could write it as that. And to a person who reads math, all of these mean the same thing. So instead of writing a really long number, you've condensed it. We've called it the scientific notation, and we've condensed it and made life easier for us. So we've just made a text out of a really long number. The same thing we can do is if we have a very small number, like this one. It is 0.000087. So this number could be written as that. Or even shorter, this number could be written as e to the minus 5. So on your calculators, on some of them, you don't have a 10 to the power, right? You have an e. Can you guys look at your calculator? You'll see an e written there, or double e. Actually, I think there's 2 e's that they write. And that's, again, the same thing for exponent. So in order to make life easier even more, instead of multiplying this number, which is actually 1,000 times 10,000, what we do is we add the exponents. Or in this case, we can, it'll give us the same thing, right? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Or we can just write it as 10 to the 7. Same thing. So we're just making life easier. In other words, I can say for any A and any B, I can write 10 to the power A plus B. I've generalized it. I've made it into a formula. So pick a number for A. 7. So 10 to the power 7 times, pick a number for B. 9. 10 to the power 9. What's the answer? 10, 7 plus 9. The answer is, so we've made our life easier. Okay, the same thing we can do when we have division. So for example, 10 to the power 4 divided by 10 to the power 2 is just 10 to the power 4 minus 2, or 10 to the 2. If we have this division, can I divide 1 and 2? So it'll be 2 times 10 to the 5 minus 3, or 2 times 10 to the 2. It just makes it easier. So for any A and any B, again, pick a number for A. 6. So 10 to the 6 divided by 10 to the 8. What will it be? 10 to the 6 minus 8, or 10 to the minus 2. See it? That's how exponents work. Okay, now how does this help me when I look at log? Logs, as far as we know, are to the base 10. So write these down somewhere. These are log rules. If you have any A and any B, you can write log of A times B as log of A plus log of B. And log of A over B, so I should write this probably properly. So this will be log of A over B, is log of A minus log of B. And Even more nicer is if you have log of a to the power n, I can write it as log of a. So for example, let me say if I needed to do log of 400 and I don't have my calculator, what do? Well, can 400 be written as divided by 2 equals 200, divided by 2 equals 100, divided by 10 equals 10, divided by 10 equals 1. So that means I can write this as log of 2 times 2 times 10 times 10. Yes? Or if I use my equation 1, I can rewrite this as log of 2 plus log of 2 plus log of 10 plus log of 10. And use this table that's above you. What's log of 2? 0.31 plus 0.301 plus 1 plus 1. And the answer is 2.602. Done. I never need a calculator. That's the beauty of the system. Okay, now how about if I have this value instead? Log of 2.5. How do I do that? Well, I know 2.5 can be written as log of 25 divided by 10. Here's a trick. Every time you see a decimal spot, move it over divided by the number of zeros. So if I move 1 over, I'll divide it by 10, which then I can use my equation number 2, which is just log of 25 minus log of 10. And 25 can be written as log of 5 plus log of 5 minus log of 10. What is log of 5? I pick this up. And what is log of 10? I pick it up from here, plug them in, I'm done. So it'll be something like 12, so 1.3 something minus 1. Yes. Absolutely. So like, let's pick a question. Let's see what we can come up with. What kind of a question could I give you? What about if I ask you, say, log of, I don't know, pick a number. 600? Actually, no, let's do a complicated one. Let's do log of 125. That's complicated. It looks complicated, right? But look at it this way. If I take 125 and if I divide it by 5, it becomes 225. Then I divide it again by 5, it becomes 5. And I divide it again by 5. This is like the LCM method. Just do the LCM method. And this will become log of 5 times 5 times 5, which I can rewrite as log of 5 plus log of 5 plus log of 5. Yeah? And what is log of 5? 0.699 plus 0.699 plus 0.699. Can someone do that now? 0.699 times 3? 2.09-ish. Okay, so how does that work when we want to talk about logs? So how do we say logs as if we were talking the terminology? So 100 equals 10 to the power 2. So the way we would say it would be log of 100 to the base 10 is 2. And mathematically, we would write it as that. Now this is 1000 equals 10 to the 3. How do you think we would say it? Logarithm of 1000 to the base 10 is, drum roll, 3, right? Good. Now the last one, is logarithm of 10,000 to the base 10 is, there we go. What if there was a 5 there, or a 6, or a 7, or a 10, right? You would say the same exact thing, except replace the last one with the number that's to the power.